we've been doing is covering everything that's in our head region that's associated with our digestive system. So when we swallow food, we push it from the oral cavity into the oral pharynx. And to assure that it does not go up into our nasopharynx, we pull the soft palate upward and posterior with the uvula to seal this off. And when that happens, we collapse the fauces, which allows us to swallow without swallowing a wad of food that's going to actually stop our ability to breathe. The first part of that is voluntary, because you're using muscles to manipulate the food backwards. Once the food enters the oral pharynx, it becomes involuntary. So if you've ever had gum or candy and you were doing something, you swallowed it. Once it's back there, it's not coming back out. It's going to be collected at the other end if it's a diamond ring or something, or be gone. And so what we then have to do is use smooth muscle contractions, which are repeated. So we use the word parasolysis to describe that. Then to continue to move the food from the oral pharynx into the laryngopharynx. Now while you're doing that, your epiglottis is actually going to be brought backwards, and muscles are going to pull your larynx, upward. So we're going to close this opening off so that food can't get in here, but it's going to continue down. Then we have a sphincter right here at the top of our esophagus called the upper esophageal sphincter. We usually keep that closed off when we're breathing, so air doesn't go down here but goes in here. When we're swallowing, we have to release that sphincter, which is smooth muscle. So we're going to relax the smooth muscle. And then the food's going to enter the esophagus. That'll establish the esophageal phase. So we went from an oral phase to a pharyngeal phase to now a esophageal phase. And what we do is we pinch the esophagus off behind the bolus of food, shorten the esophagus in front of it, and we inch our food all the way down the esophagus, which is passing posterior to our heart here, until we get to the stomach. And then we have a sphincter right here in the opening of our stomach, which is referred to as our lower esophageal sphincter, or some people refer to it as a cardiac sphincter because of the area of the stomach it's associated with. And so basically our esophagus is a muscular tube we use to inch food down, with a upper esophageal sphincter and a lower esophageal sphincter. As we get to the stomach, then we can divide the stomach into regions. So where the esophagus attaches to the stomach, this area here we call a cardia. And then this bulge next to the cardia is called the fundus of the stomach, and it's actually a storage area. So if you compared this, so for example in a lion or a wolf, they can carry about 8-10 pounds of raw meat in this area that then they regurgitate to their pups or kittens. So fortunately we don't have to do that. So as we go downward, then this is the body of the stomach. So we had cardia, fundus, body of the stomach. See this tapering right here? That enters an area we call the pylorus of the stomach. So this opening where it tapers is called the pyloric antrum. Then as we move backwards, we get into the pyloric canal. And then the stomach terminates with a sphincter that controls its emptying, which is the pyloric sphincter. And the way the stomach works is we have semi-solid material here that's being dissolved by hydrochloric acid and digestive enzymes. The more and more liquid it becomes, the more it enters the pylorus of the stomach and then is transferred to the small intestine. So some things go through the stomach quickly, other things take a long time to liquefy and move through the stomach. Now to increase the surface area of the stomach, for being able to produce digestive enzymes, hydrochloric acid, and to provide an organ that can be stretched and still have a lining that can tolerate that stretch, we have large ridges in our stomach, which are called rugae or rugae that we're seeing here. Now the stomach is curved, and so the other thing about the stomach that's really kind of cool is that we have this curvature to the outside here, and then we have a curvature to the inside here. So this inside curvature is called the lesser curvature of the stomach. This outside curvature is called the greater curvature of the stomach. And with these two curves, we actually have connective tissue that attaches to it. And so the connective tissue that attaches to this smaller curvature of the stomach, the lesser curvature of the stomach, is called the lesser omentum. And it helps suspend the stomach from the diaphragm via some ligaments that are also associated with the liver. And then a large, flat connective tissue associated with the greater curvature of the stomach is called the greater omentum. And it's not on this model, but it would be a sheet of connective tissue that would come off the stomach and cover all of your small intestines and large intestines. So that when you open someone's body cavity, you actually can't see these organs at first because you have this thin layer of connective tissue covering it that we tend to put quite a bit of adipose tissue on. So depending on how heavy someone is, then they can have quite a bit of adipose tissue associated with that. Material is processed in the stomach. We change its name. So recall, as it was traveling from the mouth through the esophagus to the stomach, we call it a bolus of food. What the stomach does is liquefy it. So once it's liquefied, then we call the product chyme. And we're going to move chyme out of our stomach into our small intestine. And our small intestine is highly coiled so that we can greatly increase surface area. And it's divided into 3 regions. So the way you could do the regions is easy to identify the upper region, easy to identify the lower region, and what's in between is a different region. So the part of the small intestine that actually attaches to the stomach is called the duodenum. So what we're seeing is the duodenum here curving around the head of the pancreas here. Now the duodenum is actually, if you looked it up in Latin, it essentially means 10 fingers, which is the way we used to measure things before rulers, is put our fingers side by side. So it's the very short portion of the small intestine. The next portion, which we're seeing in here, is called the jejunum, and it is the next in size, about 1 meter in length. And then as we get to where the small intestine dumps into the large intestine, then this would be the ileum, and the ileum is 2 meters in length, so it's the longest portion of the small intestine. Now the other thing I have to tell you is those measurements are all based upon comparing tissue that is in a recent person that died to a cadaver, because as we die, smooth muscle relaxes. So the intestine actually elongates, and so it's trying to compare those. Now, when we look at the duodenum, it's going to be primarily involved in continuing the digestive processes that we started in the stomach. As we move into the jejunum, we're going to continue digestion and begin to convert to absorption. When we get into the ileum, we've converted largely to absorption. So most of the absorption we're going to do is actually going to be done by the time chyme enters the large intestine. So the small intestine is real critical from that standpoint. So we not only highly coil this thing so that it stays all coiled up to increase surface area, but if we cut it open, we see we have little repeated ridges in here that are going around the small intestine. So these look like pleats that we would see in clothing, and so they've been called plicae. And then because they're going around the small intestine, they're called plicae circularis. And these are the big folds in the small intestine. Then under a microscope, we'd be able to see on these plicae circularis little upward finger-like folds called villi that greatly increase our surface area. So one of the patterns we'll see in the digestive system is an elaborate folding system of things to greatly increase surface area and certain cell populations. So one of the cool things, which we can't do on a model, which is personally why I'm really excited about a cadaver lab, is that we could actually take these small intestines and try to pull them out. And what we had noticed is what's keeping them all in place are thin segments of connective tissue. So on the models, if you turn it over, then they're showing all this connective tissue that's connecting to the small intestine, and it connects all over. And so one of the most generic names we can give for flat sheets of connective tissue like this is a mesentery. So this is a reference to the mesentery of the small intestine that we're seeing here.